Madam, shall we begin, madam? Or shall we give another 2 more minutes for this? Shivashankari,
Yes,
madam.
let us give some couple of minutes. Let them come.
Okay, madam.
Okay.
Okay, madam. Okay, madam. Then here from our college, Dr. Shivashankari, madam will be giving the introduction about the expert, madam. Then you can start, madam. Okay, madam.
Okay.
Okay, madam. Thank you, madam. Thank you. Thank you. Not thing. You call madam over phone, sir. Shivashankari, madam. Madam. Yes, madam. Start, madam. Please start, madam.
இரு இப்பதான் பேசவே போறேன். அங்க ஒரே ஆட்டோ சவுண்டா இருக்கு. Yeah, good evening to everyone. Sir, am I audible, sir? Kanan, sir?
Yes, madam, you are audible, madam. Please proceed.
Okay. So, good evening to all the participants. So, let us begin the session 2 of the second of our FDP. So, we have with us our session speaker, Miss Janaki ma'am. So, let me introduce our speaker profile. Janaki ma'am, she is currently working as an assistant professor in the Department of ECE at Sri Sairam Institute of Technology. She obtained her UG degree from University of Madras in first class with a distinction and Masters in Applied Electronics from Anna University. She has 14 years of experience in teaching. She is pursuing her research in the field of deep neural networks in image processing. She also published 5 Scopus indexed papers and 8 papers in UGC journals. And she also authored a book chapter in machine learning techniques. She published a patent in image processing. So with this brief note, now I'd like to invite and welcome Janaki ma'am to take over the session.
Thank you, ma'am. Thank you so much for your kind introduction about me. So good evening to all learned professors organizing, coordinating, attending this 5 days FDP on advanced signal processing, communications using AI and ML techniques. So before starting the session, I would like to thank the management, principal, HOD and deans of both the institutions for providing me this opportunity to deliver the lecture on machine learning techniques in wireless communication. Sir, is my screen visible, sir?
Yes, madam, it is visible, madam. You keep it in slideshow and proceed.
Yes, yes.
Okay. So without any further delay, we'll get into the outline. So today in this session, we are going to see what is 5G network, an introduction to machine learning and machine learning algorithms in 5G overview, ML aided spectrum sharing. So this is the use case we are going to discuss, how machine learning techniques helps to share the spectrum between different radio access networks. Then what are all the software tools available for machine learning in the field of communication, in the field of signal processing and image processing, and finally the research areas of ML in advanced communication. So just we want to have a glimpse of network evolution. So we started from 1G network in the year of 1979. This is the first generation networks. Hope we are the generation might have used these phones at our home. Okay, so this phone is used only to transmit our analog voice. Other than this analog voice, nothing can be transmitted using this 1G network. So the quality of the voice service over this telecom service are even poor. So in order to improve the quality of the voice service, the one from 1G we migrated to 2G in 1990s. In early 1990s, there is a migration from 1G network to 2G network. So in this 2G network, we have used digital modulation techniques to convert our analog voice to digital voice, and then the device which come up in 2G network support voice communication. In addition to that, you can transmit some text, that is short message services. This will also we have experienced in our real life. So in later 90s, the evolution or migration from 2G to 3G. so which incorporate some video calling in the device, and then we can play some online games with minimum internet speed. Okay, so next one is in 2000, in late 2000s, nowadays we are using 4G networks. So this 4G networks can provide a upgraded video quality and various games and making the streaming more smooth even that provided by 3G network, and the network speed is much faster than 3G network. Say for example, now we are using Microsoft Teams. So this video streaming and voice over the internet and real time conferencing can come under the examples of 4G network. So this is the network which we can dream in our near future, that is 5G networks. So this network will monopolize in the next decade. So the main objective of this 5G network is all the devices are going to be connected to the internet. So say for example, smart homes, smart cities. So everything, every devices at home, like refrigerators or air conditioners or washing machines or laptops, everything is going to connect to the internet, and it is going to provide a reliable service with low latency. So that is all about this 5G network. So it can connect more number of devices as well. So the population connected to this 5G network will be even high compared to that of 4G, and this network is going to offer as the speed 100 times better than our 4G network, and the data traffic also it is going to offer with minimum tariff rate, and 20 gigabits per second will be the peak data rate promised by this technology to offer to its end customers. So this is just the evolution of the networks from 1G to 5G. So today's in this session we are going to concentrate much on 5G networks and how ML is going to role play this 5G networks. So as I said earlier, this 5G network is a faster network that has the potential to transform the internet. Even I can say a tactile internet is possible with the advent of 5G networks. Tactile in the sense we can have a reliable network with low latency. With low latency here, I mean is the speed will be much faster. There won't be any delay in conveying a message from one point to the other point. So that is the objective of this 5G network. So this 5G network is comes under software defined network under the broad category called network virtualization. Uh, Say for example, if I want to add some new feature, then I need a new hardware to implement that feature. But in future networks, we don't want any hardware replacement. Instead, everything will be programmed in cloud, and that hardware component and functionality of the hardware will be realized in the software itself. So such networks are called software defined networks. So that those networks are compatible even if you want to update any new features. It is simple to update the software rather than replacing the hardware. So this 5G network offers 100 times capacity than the 4G network, and it offers a very low latency. Latency here is nothing but the delay in transmitting or conveying the information between the transmitter to the receiver. So for example, in 3G networks, if I want to download a film which is for the duration of 2 hours, it will take 26 hours, nearly 26 hours for me to download the picture and view the picture. Later, as we migrate to 4G, the same application I can do with my 4G network in just 6 minutes. So with my 5G networks in future, it is possible to download a movie in 3.6 seconds. So that kind of internet speed and that kind of reality we are going to enjoy with the advent of 5G networks. So comparing the existing frequency division multiplexing techniques and 5G networks. So the orthogonal frequency division multiplexing, we are going to use the modulation technique in 5G. So the below figure, we have 6 different users that can use the channel in terms of frequency, which means that all the user can utilize the channel at a time, but they cannot allow to use all the frequency at the specific time. So the same application with the with this frequency I can utilize in 5G network. This concept is called orthogonal frequency division multiplexing. So in orthogonal frequency division multiplexing, all the 6 carriers are orthogonal to each other, taking care that there is no interference between the 2 carriers. So these are the 3 signals I want to get mixed using orthogonal frequency division multiplexing with this delay. So I hope this graph, pink color, blue and yellow color. So there is a minimal delay, and then the signals will get mixed up using different carriers, and all the combined signals are ready to transmit inside the channel. To ensure the orthogonality, if you analyze this picture, so when this signal, that is the signal which is pink colored, reaches its maximum peak value, the signal with the green and yellow reaches the null value, means that this signal gone down to 0, only this signal is at the peak value. So in this way, if we mix this signal, we can ensure the orthogonal nature of the carrier. So this is the peculiar property which avoids interference between the 3 signals. So this is the modulation technique we are going to use in 5G networks. So for example, here we have taken 3 signals, but in reality, we can go for n number of carriers. Those n number of carriers can be mixed up and combined in a channel with minimal interference. So next one is machine learning. So later on, we'll mix how machine learning finds its application in 5G networks. So there is a big area called artificial intelligence, which provides machines the ability to learn automatically and improve the experience without being explicitly programmed. So whatever the task that can be done by the human, that will be done by a machine. So we'll be teaching the machine that these are all the data we have, and you have to take the decision according to the data. So a program can be done, the machine will learn from that program, which is nothing but the algorithm, and later on the decision will be taken by the machine in a much better way, depending upon its learned experience. So this is just an analogy to a new child who doesn't know which is a cherry, which is an orange, and which is some apple. So we'll be teaching the child and showing the picture that this is the apple and these are all the features, and this will be the taste if you eat such kind of fruit. So the child will be learning on the way we teach the child. The same thing here, the machine will learn on the data inputs what we are going to feed. Later on, the machine will take the decision based on the learned experience. If any mismatch is that, we'll be taking that as error and feed back the error to the algorithm, and then it learn from that error, correct the error. So this is the cycle. Once the algorithm converges, the model is ready to be implemented. So this is machine learning. So the first one is, so there are 3 different types of machine learning available. So the first one is supervised learning. Supervised learning is nothing but we are going to train the machine with some data labels. So if these are all the features you identify, then take the decision that it is a cat. So if there is a curved tail, and if the height is like this, and if the ears are like that, so if this is the features you are going to identify, then classify that as a dog. Okay, so every data will be a labeled data in case of supervised learning. So which is nothing but a learning with a teacher. So the teacher will tell, so these are the questions, you have to learn, and these are the concepts you have to learn. Accordingly, there will be one central entity which guides the mission. So that is supervised learning. So the supervised learning can be used for classification and regression problem. So classification, in the sense, we can in wireless network, wireless communications, if a transmitter is in a particular base station, if it consider it is a mobile transmitter, so during its travel, if there is a hard decision in handoff, whether the transmitter should be connected to which of the base stations near to it, so then that kind of problem is called as classification. Regression, in the sense, it will return, the machine learning algorithm will return us some continuous value as the output. Say for example, to predict the price of the house by giving some features. The features are nothing but where the area where the house is located, and what is the square feet of the house, and how many bedrooms the house will have. So everything depending upon the feature, the algorithm will return the value that this is some 30 lakhs will be the price for the house, or like that. So that kind of problems are called regression. So supervised learning will work very good for classification problem as well as for regression problem. In machine learning technique, what we are, sorry, in wireless communication, we are going to consider the signal power received from the receiver, received from the transmitter, will be considered as the regression problem. Why? Because it is going to return some concrete value. So this much of dB will be received from the transmitter to the receiver with the presence of obstacles or without the presence of obstacles. So the next one is the unsupervised learning. Unsupervised learning is nothing but self-learning or learning without a teacher. In unsupervised learning, it is going to address two kinds of application. One is clustering, another one is association. Clustering, in the sense, the pattern recognition and group recognition itself will analyze to which group the new data should belong to. So that is called clustering and association. So that is an example for unsupervised learning. So reinforcement learning is learning according to the environment. So all the mobile applications, games, what we are using, online games, what we are using is based on reinforcement learning. So in this reinforcement learning, the agent will learn from the environment, and according to the current state of the environment, the agent can earn a reward or any punishment. So according to the action taken by the agent, it can be rewarded or it can be punished. For example, if you want to play an online board chess game, the main objective of the user is to win against the machine. But the machine will be trained and it will be programmed in such a way that what are all the highest possible toughs that the other person will give. So it will come up and come out and with all the things, and it will be rewarded. So once which will be the winning board, that board will be taken as a reference, and again if there is any error happened, the program will be trained according to that. So now, so this is the overview of machine learning techniques. Now let us see why machine learning is very important in 5G wireless systems. So existing 4G networks use internetworking protocol broadband connectivity for transmission. So which offers one poor efficiency. So and moreover the networks are not reliable, and we are feeling some delay in transmission as well. So in order to overcome all these things, we are going to apply machine learning algorithms to make our network more efficient. So AI and ML is the promising technology that allows the 5G networks to be predictive and proactive. Intelligent base stations can be designed, and the base stations can take the decisions by themselves. So base stations are the one which are going to serve our lakhs of customers. So depending upon the movement of the customer, depending upon the signal strength, depending upon the ongoing traffic conditions in and around, the base stations can take the decisions by themselves. Such base stations are called intelligent base stations, where a ML classifier will be given a continuous input to the base stations. So depending upon the collected data from the ML classifier, decision can be made by the base stations. So the mobile devices can create adaptable clusters based on the learned data. Even our handheld device, if it have that intelligence, the device itself will associate to the nearest base stations based on the learned data. So altogether, it will all improve the efficiency, latency, and reliability of the networks. So as I said earlier, there are three kinds of machine learning techniques. We have supervised learning, unsupervised learning, and reinforcement learning. How these machine learning algorithms can be used for different applications in wireless communications. So the first, in supervised machine learning, it can be used for classification and regression. So first, regression models. So regression models separates the data based on the function. So regression model is going to return some continuous value as the input. So if I want to calculate the power received from the transmitter at any receiver side, I can go for regression machine learning model. So the imagine environment that there is a transmitter and receiver. Between them, air will be acting as an interface to carry the signal from the transmitter to the receiver. So there are two possibilities that the signal can reach the transmitter from the receiver in line of sight, which means that there is no obstacles in the environment. The second possibility is that there will be some obstacles that can be present between the transmitter and receiver. So in the second scenario, what it will happen is the obstacles here I mean is there may be a large trees, or there may be high rise buildings in case of urban areas, or there will be some moving obstacles like cars, trucks, or buses, whatever might be. So if there are obstacles present between the transmission path between the transmitter and the receiver, the received signal quality will become poor. The received signal quality will become poor, and the strength of the signal will also be less. So those kind of traffic monitoring can be done by a machine learning algorithm, and it can predict how much the signal will go degraded, and the information can be sent to the base station and how to improve this power. Okay. So such regression models finds the applications on channel and power distribution. So the regression model are a very good model to manage the external channel environment and calculating the received signal from the nearby transmitters or nearby reflectors. So if the signal strength will be more if it is from the nearby reflectors, and the signal strength will be very poor if it gets reflected from the distant reflectors. So in such case, this regression model finds the applications in wireless communication. The next one is K nearest neighbor. So this diagram tells us the K nearest neighbor. So the K nearest neighbor is used for energy learning. So energy learning in the sense, in 5G networks, we are going to use a concept called spectrum sharing. So in spectrum sharing, all the network, that is Wi-Fi network or LTE network or voice over LTE network, long-term evolution network, both are going to share the same spectrum. So if any clusters or any devices which are using any particular services, they can be combined and grouped to form in a single cluster. Depending on that, channel will be allocated and their energy will be calculated. So this is called forming a clusters from the data received from the data centers. The algorithm used for this clustering application is K nearest neighbor, which is one of the supervised learning algorithm. The next algorithm is support vector mission. So support vector mission helps in handover solution and handoff solution. So handover solution, when a transmitter is near to the boundary of the two base station, then there will be a hard decision to take whether it has to hand it over to the next cell or to the nearest cell. In support vector mission, the boundary, we are going to increase the boundary of the hyperplane, where the vector which is present near the boundary will belong to that group. The vector which is away from the boundary will belong to another. So this is also a classifier. Support vector mission is also a classifier, so which makes the handset or which makes the device to allocate in a particular cell. When we move from one cell region to another cell region, there should be a handover of base station from this region to the region without compromising on the quality of the call. We should not even feel that we have roamed from one point to the other point. So without knowing that, the handoff should be a smooth handoff. So for that purpose, we can use support vector machine learning technique. Next one is unsupervised machine learning technique. So in unsupervised machine learning technique, there won't be any label data. So we have to form some clusters and we have to make some groups. So the principal component analysis and independent component analysis. So that is nothing but feature extraction. Say for example, if so many features, input features are there for the machine, at one point of time after a threshold value, if we make the machine to learn with n number of feature, the performance of the machine will be degraded. So we have to see the correlation between the features first. If the correlation is maximum, then we can drop the feature with the necessary feature. If we make the machine to learn that feature, then the applications will be, performance of the machine will be high. So principal component analysis and independent component analysis finds its applications in smart grids and cognitive radio. So cognitive radio is a 5G radio network. Cognitive radio is a 5G radio network. So this is going to use the unlicensed spectrum. So in a survey, it is found that though we got a license for the spectrum, most of the times the spectrum will be left unused. So cognitive radio is the radio which will sense the spectrum availability. It will sense the spectrum availability. If it finds that if some part of the spectrum is unused, this radio can utilize this spectrum and transmit the information digitally. So if the licensed user comes into that spectrum, so this radio should find the another spectrum, vacate the current spectrum, get into the next spectrum, and then it can provide the service. So this is an intelligent radio. So this is a mobile radio which have some good cognitive skills and cognitive ability, that it will keep on monitoring the spectrum availability. If it is free, it will use that spectrum. If the spectrum is occupied or the owner of the spectrum comes into the picture, it will find the next spectrum, it will vacate the current spectrum, get into that spectrum and provide it seamless service. So we can have good connectivity and seamless service from cognitive radio. So that will be the future network. So next, k-means clustering. K-means clustering is used for organize the data from heterogeneous networks. So heterogeneous networks are nothing but the networks which have different compatibility or different modulation techniques. Okay, example, Bluetooth will use its own modulation technique, data rate. Wi-Fi will have its own modulation technique, data rate. LTE will have its own. So if all these networks combined and then it is providing its service in a particular platform, then k-means clustering is an algorithm which is used to organize the data and schedule the data according to the clusters. So the cluster center will be identified, and from the cluster center and each data points we will be finding out the distance between the cluster center and each data points. So that distance is called Euclidean distance. If we have a minimum Euclidean distance, the data point will be grouped in that particular respective cluster. So this is the functionality of k-means clustering in machine learning. Next one is reinforcement learning. So in reinforcement learning, we are not sure about the environment. Environment can take any decision randomly. So here comes the probabilistic model. It may be based on conditional probability or it may be based on joint probability. So Markov decision process or Markov chain and Monte Carlo methods. So those methods comes into the picture that will take the decision based on the current state of the environment. So if the actions are rewarded, then this policy or the learning strategy will not be changed, will not do any update to the learning strategy. If suppose the actions are not rewarded, instead the performance are very poor, we need to change the policy and the learning strategy of our algorithm. So this can be any Bayesian network or any Markov decision networks can support if we do not know how the environment is, how the environment will be and how the agent will behave according to the environment. In that case, we'll go for these kind of algorithms that is called as reinforcement learning algorithm. So next one is Q-learning. So Q-learning is a learning algorithm comes under reinforcement learning. So where it determines the best action with respect to the current state. This finds its applications in microcells, small cells, and macro cells. So in wireless communication, we can categorize the transmitter as two types. One, the transmitter will be a fixed transmitter, or the speed of the transmitter will be minimum. Say, for example, we are walking and then we are talking over to a friend who are living in some distant area. The another transmitter will be the mobile transmitter whose velocity will be high, means that the transmitter is present in some moving car. So the first case, if the transmitter is a slow transmitter, slow moving transmitter, it doesn't require that number of handoffs. So that transmitter can be occupied in a small cell. So the performance will be good. But the transmitter whose velocity is high or who is moving in a faster rate, if I put that transmitter in a small cell region, I need to give so many handoff to the transmitter. So those moving objects should comes under macro cell categorization. So these kind of things according to the environment and according to the condition of the transmitter, the decision should be taken whether they have to be provided fixed in a small cell area or they have to be fixed in a large cell area. So these kind of decisions and applications we can use in reinforcement learning. So this is the overview of ML algorithms in 5G networks. So now machine learning in wireless communication. So machine learning is great for complex problems where existing solutions require a lot of hand tuning or the traditional approach cannot give that much yield. So in that situation, we can go for machine learning. Another difference between machine learning algorithms and traditional approaches, here in machine learning, the feature extraction can be done automatically. Whereas in traditional approach, humans have to collect all the details from the data centers or from the servers, and then we have to analyze and we have to take some decisions. So automatic feature extractions and the correlation between the redundant features can be easily done with the help of machine learning techniques, but that will be a bit tough in traditional approach. So machine learning tasks even detect anomalies in the network during some natural calamities or something happens. So it can detect the anomalies where the network has gone down, how it should be reliable, and what are all the future scenarios, and how the network should adapt to the fluctuating environment and the insights of the complex problem with larger data set. Everything will be taken care by machine learning algorithms. And moreover, the parameters and the estimating functions. The parameters in wireless communications is how much the signal will get affected by the noise, and how much the received signal power we got, and link power budget design. So everything, these parameters and estimating functions like loss functions will be predicted easily by machine learning algorithm on the available data. So this is the layout of machine learning pipelining. So first, problem definition. So the problem statement should be clearly written here. Say for example, I want to predict the signal strength between a transmitter and receiver which are present 5 kilometers away. Assume there will be some obstacles present in the environment. So the data will be collected from different multipath. Why? Because if there are so many obstacles, the signal will get reflected on different obstacles, and the signal will reach the destination with a different time, and the signal will reach with a different intensity. So those kinds of data should be collected. So then the data preparation was is nothing but data cleaning. So we want to see whether the received signal strengths are unique value or any repetitions we got. If we got any repetitions, then we can say that some obstacles, some same set of obstacles are providing the same type of disturbance. So those feature can be eliminated, and we will not be taking mean of one of that value. So that is called data cleaning or data preparation. Once the data preparation or cleaning, this is called feature engineering. So here comes our principal component analysis and independent component analysis of machine learning into picture. Data collections can be supervised machine learning or unsupervised machine learning. Then model training. So model training in the sense, so these collected data will be given as input to the model, and we'll be expecting some output, and we'll be checking whether the expected output matched with the output obtained from the algorithm. If both the outputs are same, then the model is ready for evaluation, and that model will be the best model for implementation. So if there is any changes in that, we need to change the hyperparameter of the machine. That is, weights can be updated. So many back propagation networks or perceptron methods or radial basis functions or interpolation functions. So many techniques are available to change the weights to minimize the loss function. Here the loss function means the difference in the expected output and the actual output. So if at all everything is over, then that particular model is ready for deployment. So this is the overall pipelining of machine learning architecture. So this is an example for that of pipelining architecture in wireless communication. So here I have a raw data collection. So I have so many equipments around me. So UE refers to user equipment, and this is the base station, and network equipments like routers or links or gateways, whatever it might be, and then measurements from some other antenna, and then data centers. So here I have taken 5 different devices. I'm going to collect the data from 5 different devices. So these 5 different devices will have different format of their data. So every format will be collected by the raw data collection center. So from the antenna, we can expect some electromagnetic radiation of particular frequency. The base station can emit signals at some 900 megahertz if it is a cellular architecture. So the user will use uh, different notations to represent their signal. So every signal from every possible equipments are collected by the raw data collection. Then the data should be cleaned. So this is the next phase. So this is called a supervisor. So the supervisor will label the data. So if this is the format of the data, please assign that this data comes from a base station. if you receive the signal at some particular frequency, that 900 megahertz frequency, assign the data, that is the data is from the user equipment or base station or from any routers like that. So here the labeling will be done accordingly. Next, the data will be splitted for training and testing. 80% of the data can be used for training, and 20% of data can be used for testing. More the training we give the machine, the efficiency will be more. So then we can use any model here. The neural networks comes into the picture. Depending upon our applications, we can use any artificial neural networks. Then we'll be seeing the output of the model. So if the test data and the training model matches with each other, then that is the most valid model, which is get ready for deployment or implementation. So the validation will be done by use of new unlabeled data. So any new data we got, that data will be given as input to the validation model, and we can check whether the prediction done by the machine is right or wrong. If we are not satisfied with the prediction taken by the machine, then there will be error calculated at this output. So this error data will be fed back to the training model. So this training model is nothing but neural network depending upon the applications. In machine learning, we can use perceptrons, or we can use back propagation networks, or feed forward networks, or radial basis functions, whatever we can use. In case of deep learning, which is the subset of machine learning, we can use UNet or VNet or GoogleNet or AlexNet, whatever might be the model we can use to test our efficiency. Now transfer learning finds the maximum gain in classification accuracy. So this error will be fed back to the model. So the model will update its weight according to the error, and new decision will be obtained from the model. Again validation will be done. Again we'll see whether they are matches with each other. If they matches with each other, then we can say that the model is ready for implementation. So this is the how the machine learning model works. So this is the use case we are going to see how spectrum sharing can be done using machine learning, and network virtualization can be done in machine learning. So recent advances in machine learning for radio environment based on context awareness and uses the obtained information from different sources, and that will create as slices. Slices is nothing but partitioning the major network into sub networks which are capable of doing some specific task. So the main motive of spectrum sharing is two users can coexist in the given spectrum with zero interference. So that is the objective of spectrum sharing. So the best example for spectrum sharing is we can take cognitive networks as an example. In cognitive networks, those networks are unlicensed networks, whereas licensed and paid networks will use the particular frequency spectrum. In the wireless sensor networks, the cognitive radio finds that some spectrum is unused. It will try to grab the spectrum and come and sit inside the spectrum and start its transmission. So if the owner of the particular spectrum gets in, then the cognitive spectrum should vacate, but it cannot vacate at that moment. There will be some time that both the users, secondary user as well as the primary user, will coexist, and then they will see whether the transmission signal strength or energy of the secondary user pulls down the primary user. If they are not pulling down the primary user, both can coexist in the same spectrum and they can start their transmission. If the signal strength or energy pulls down the performance of the other system, immediately the secondary user, why? Because the licensed user has the right of the access to utilize that particular spectrum. So the user which is using at free of cost has to vacate that medium. So in that context, the cognitive user will go out. So this is called coexistence. That coexistence is possible, and that energy monitoring can be done by machine learning algorithms. And the machine learning algorithm will also monitors the ongoing traffic over air. In 5G networks, the medium for transmitting the signal is air. So we have to define a proper air interface and proper waveform coding techniques to transfer the message from transmitter side to the receiver side, and media access control techniques, and the amount of transmission opportunity in the sense no one should play monopoly in the network. Everyone should have equal chance for their transmission, so that we can have so many multiple access techniques like TDMA, FDMA, CDMA, everything we have. Okay, so those kind of things should also be taken care by the machine learning algorithms, and how frequently the opportunities are arriving for the expecting transmitters to transmit the information. Making the best decisions for the best combinations to insert the new traffic in physical limited resource, and recognize persistent and bursty channel activity. So these are all the different RAT in the sense radio access technologies. Wi-Fi is different, LTE is different, and DVB-T is different. So these three different networks are going to share the same spectrum with minimum possible delay, that is called as latency. So in order to achieve, or in order to satisfy all these requirements, the only promising approach is that the machine learning approach shows the promising results for spectrum monitoring and awareness compared with traditional solutions what we are using at present. So radio access technologies must coexist in the shared spectrum. This trend is the accelerating trend with the advent of 5G networks. The usage of flexible radio access networks with high configuration capabilities presents new opportunities for interference coordination in shared spectrum scenarios. And slicing is a concept that across software defined networks. So already in the initial thing I said what a software defined network is. So software defined network, if we want to implement any new feature, we are not going to upgrade our hardware. Instead we are going to written everything in the software, and then we are going to upgrade the software. That is called as network function virtualization. Network function virtualization, that is the key concept in 5G standards. It involves sharing the underlying network infrastructure between multiple tenants by assigning each tenant a virtual network with a portion of network's resources known as network slice. So this slicing also requires some level of abstractions and some protocols. We cannot slice the network as in what we require. Instead, we have to do some level of abstraction. The level of abstraction can be done on some protocol which may be based on some IEEE standards or ANSI standards. So everything is a research area, and researchers are going in this field. Network function virtualization. Depending upon some protocol, we can do some abstractions, and we can we can virtualize a physical hardware. So the virtualization of wired network components. So the wired components are link, router, and network interfaces. So their functionalities can be embedded and written in embedded language, and then this functionality can be utilized at the TCP port or at the UDP port or in any networking in virtual machines. So the deep learning applied for spectrum awareness and radio virtualization is used for efficient spectrum sharing among the coexisting network. So these new features collect the new approaches can collect features that go beyond simple waveform classification, say for example frequency, bandwidth, or what is the frame duration. So right now what is the trend or what is the architecture we are following is, if we want to add some feature, we can add the chip, share the chip in time division manner, that is one function at a time. Example, Wi-Fi access point broadcast a message for channel switching. At that time the other access points will be stopped in utilizing that function. So if I want to use one more thing also to use that particular thing, we'll be having a duplicate chip, one for each axis, which increases the complexity as well as the power consumption, which also leads to potential waste of the resources. So keeping these two things as a disadvantage and keeping these two things eradicate in future generation networks, we went for a concept called radio virtualization. So virtual radios are created on demand instead of duplicating the chips or instead of adding the hardware to the existing devices. A physical radio can be instantiated into multiple virtual radios. The virtualization process is application transparent, and it offers some uninterpreted services from the upper layer that is indistinguishable from physical radios. So even though we are going for virtualization, the functionality provided by the virtual networks are 100% in match with the physical radios provided. So we can minimize the power consumption, and then we can minimize the size of the devices. So everything is a better opportunity if we go for virtualization. So the sorry, I got stuck with the system.
Madam,
Sir,
your voice is not audible, madam. It's
it
okay, madam.
is it audible, sir?
Now it is audible.
Okay,
Yes, madam.
sir.
Yes, madam.
I have some issues at my end. Sorry, sir. Okay.
No problem, madam. No problem. You
Okay,
please carry on.
okay. So this is the solution for the problem we have discussed earlier, that is network virtualization and spectrum sharing. So we'll be having an ML classifier. We'll be collected data from different wireless channels, and we'll be calculating what type of modulation and what is the duty cycle that every signal undergone, and what is the burst length of the traffic, and what is the frame duration, and what multiple access techniques it have used. So everything, this ML classifier will collect the input from the different channels. The classifier will label the data, and then the classification output will be given to the hypervisor. The hypervisor is nothing but a radio channel monitor. The hypervisor is nothing but the radio channel monitor. So the hypervisor will decide how many slices of virtualized radio it has to do from the same hardware, and the services are mapped to the required channels. So in this case, this part will be the purely software part. The decision will be taken based on the outputs obtained from the machine learning algorithm. Here we are not going to use any hardware part. Instead, we are going to run code, and then accordingly we are going to assign a signal to the channel. So this is the working principle of the hypervisor. The radio hypervisor handles N services from the host PC using a single SDR device. SDR is nothing but software defined radio. We identify the data streams from different services by their TCP port, and then it will slice the data, and the slice identifier informs the SDR to send the data on a particular channel. Our hypervisor uses the output of the classifier to decide which channel will be used for which service. Why? Because we have n different services. One we can use for voice, another one we can use for teleconferencing, another one we can use for some mail sending emails or whatever might be. Okay, so depending upon the different types of applications, the hypervisors uses the output of the classifier. Here the classifier will the hypervisor will map which channel should perform what type of service to the user with good quality and low latency. So this is the internal architecture. Here we'll be using a FPGA module for radio concept virtualization, and our main motto is to instantiate the radio interfaces according to the required services. We'll be finding out the best combination between the set of channels and services. One channel is good in providing a Wi-Fi, handling a Wi-Fi traffic. Other channel will be good in providing a voice.
ఎన్ని సైడ్లు స్క్వేర్ కి 4 సైడ్స్ కదా 1 2 3 4 ఒక సైడ్ 6 రాసుకో side area of a square equal to area of a
So that
square equal to
will be utilizing the
side into side. Side.
The other channel will be utilizing the some other services. For example, voice over LTE networks or voice over IP networks. So which data we are going to send, accordingly the channel should be matched. So next, the potentials of ML and 5G. So this is the active research topic going. So one is EMBB. EMBB stands for Enhanced Mobile Broadband Technology. Enhanced Mobile Broadband Technology. So this will allow for new applications with higher data rates. That is, this potential is possible with the advent of tactile internet. Tactile internet in the sense anything can be possibly connected to the high speed internet with much reliable connections. So this is EMBB. So it finds its applications in ultra high definition video streaming. So this is the future potentials of 5G technology. The next one is URLLC. So this is the main goal of 5G networks. So URLLC stands for ultra reliable low latency communication. Ultra reliable low latency communication. This can find its applications in healthcare and any remote surgeries, or vehicle to vehicle communication, or autonomous driving. So this will find its application. The last key factor of the 5G technology is MMTC. MMTC stands for Massive Mission Type Communication. Massive Mission Type Communication. So that is IoTs. Every devices at homes and every devices in all the cities, in countries, everything will be linked to the internet. So IoT comes into the picture under MMTC. So smart homes, body area networks, and Internet of Things, everything comes under MMTC. So these three will be the major design goal in 5G networks, and all the three key features and services will be provided by the 5G in near future. So to simulate 5G by a machine learning algorithm for wireless communications, we have a toolbox, that is statistics and machine learning toolbox, available with MATLAB, and deep learning toolbox is also in MATLAB, and Python scikit-learn, it requires Anaconda, and TensorFlow from Google. Even we can make use of Google Colab. We don't need to download anything. Everything, our program can get recorded in the cloud itself, and we can run the program. We can see and we can get the data sets from so many available resources like Kaggle, MNIST, PubMed. If we want to get some image or medical data, we can get the data from PubMeds, and data on wireless communication data. So that will not be picture data. You will have some raw data. So that is available in Kaggle as well as in MNIST, and we can use Keras or Cafe, which will find its application for feed-forward networks and image processing and convolutional neural networks. So this is the other applications of machine learning in advanced communication. That is identifying the spectrum usage by unknown systems. So we are saying that everybody can use any spectrum, available spectrum, and everybody can coexist in the spectrum. But to keep track who is utilizing that particular part of the spectrum, to ensure authentication and security, we can use clustering machine learning algorithms to keep track of who is utilizing the spectrum. And then the machine learning algorithms are used to detect anomalous wireless links in IoT networks, and then regression models can be used for path loss modeling in urban environment. We know that urban environment are mostly densely populated environment, and for mobile communication there will be so many obstacles between the transmitter and reflector. So whatever the signal we are going to transmit, that signal cannot reach the receiver in a line of sight path. It will get reflected in multipaths, and the multipath component in the mobile channel will reach at some different time, so the signal strength will also be reduced. So how to come up with a best model that will reduce the path loss in urban environment? We can use machine learning algorithms. And modeling received signal power in mobile communication, we can use regression model. As I said, a regression model returns a continuous output. So this we can use regression model. Other things we can go for some classification model. So this is how the machine learning can find its applications in advanced communication. So the overall, what are all the types of algorithms that we can use, we have discussed. Thank you. Thank you so much for listening. Thank you, sir.
Yeah, 1 minute, madam. Okay, ma'am. Any other from the participant side, any questions are there? Dear participants, you can raise your
No,
questions.
sir.
Participants,
Yes, sir. I don't have any questions, sir.
okay. Yeah. If any, yeah, we will give 1 or 2 minutes. It will be available. You can you can raise your questions. Madam is ready to answer your questions. It's related to AI and ML in the wireless communication. Is any questions from any participants? Yeah. Since there is no question from the participants side, Madam, thank you, ma'am, Janaki, ma'am. Thank you very much for your wonderful presentation. Since it is very new and emerging area, yeah, we are very happy to receive this presentation. Thank you very much, madam.
Thank you, sir.
If possible, we will meet in some other FDPs or workshops also, madam. Thank you very much, madam.
Thank you so much, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, madam. Thank you, madam.
Thank you, sir. Thank you, sir. Thank you so much.